In the previous video, we had discussed a problem. There was a block floating in free space and it was found to be accelerating in this direction. We knew two of the forces acting on the block and we had to find the third force. How can we solve this problem? Let's start with the most basic equation we need to use to solve this problem. That is, F net is equal to mass into acceleration. So the net force acting on this block is in this direction, having magnitude mass into acceleration. Next basic equation we will use is F net is equal to sum of all the forces acting on this body. In this expression, we know three forces, so we need to find the fourth by rearranging this expression and finding this term. Now, as these are vector quantities, they cannot simply be added. We need to resolve them first. So let's first take an axis and break the same expression into two equations for each dimensions. Here we are balancing components of the force in x and y direction separately. Basically, we now just have to resolve each vector and put in the values of their components in this expression, and we will get the x and y component of the third force. Simple, isn't it? Just to broaden our understanding, it should be mentioned that we could have taken any axis. Let's take an axis oriented in the direction of acceleration. Now, how do we know which one is better? In this form, we need to resolve two vectors, F1 and F2, and F net is already resolved. And in the previous configuration, we had to resolve two vectors for our analysis, F net and F1. So in this case, there is no specific advantage of using this axis over the first one. But there will be cases when it becomes helpful to choose axis oriented in a particular direction. We will deal with them as we solve more problems. Now we will come back to Earth with this block of ours. The special thing about Earth is that everybody on its surface experiences a downward gravitational force equal to mg. So this block too would experience a force mg in downward direction and a normal reaction to the ground in the upward direction. As the block is at rest on the ground, that is, it has zero acceleration, we can say that net force, that is sum of these two forces, will be zero. Hence they will be equal in magnitude and opposite in direction. Since this is generally the case, the normal reaction is equal to mg. But for cases when there are additional forces which have components in vertical direction, the value of normal reaction changes. There is one more case in which the value of normal reaction might not be mg. Let's take the case of this block resting on the floor of a lift. The lift is accelerating in the upward direction with acceleration of a. Can we find the value of normal in this case? And would it be greater or lower than mg? Let's find out. We will draw its FBD first. The forces acting on this block are mg and the normal reaction. The block is in constant contact with the floor of the lift, which is accelerating in upward direction. Hence, the block is also accelerating in the upward direction with the same acceleration. Therefore, the net force acting on the block is m multiplied by this acceleration, and it is directed upwards. Hence, the sum of the two forces should be this in the upward direction. So, n minus mg is equal to ma. From this, we get n as being equal to mg plus ma. So, for this case, normal reaction is more than mg. Try to do the same problem for the case when the lift is travelling upward but is deaccelerating at a rate with magnitude a. What will be the normal reaction in this?